I'm checking tubes with my Hickok 600A this time around because I just happen to have it out and set up. First up, I'm checking the 6AU6s, and the very first tube I put in there, well, what do you know? Shorts. Now obviously the set was working, so can't be a terminal problem with this tube, but I would hope that putting in a better tube would help the set perform better. I didn't find any more tubes with shorts or weak tubes, but what I did find is that two of the tubes were 6CB6s, and I don't recall this using that, but somebody has indeed written on there 6CB6. Well, service info sure doesn't say that. It's got 6AU6s everywhere. And I checked the tube chart inside the cabinet. It also says 6AU6s across the board. So that's what I've put in here, and let's see what difference it makes. Alright, let's see what difference that makes. Fortunately, still not so hot. Alright, well, I will move on to finish recapping the electrolytics and seleniums, and then we'll see where things stand. I finished rebuilding these two caps, and I'm getting ready to install the rebuilt third one. These two are not covered with cardboard, so I did my usual uncrimping from the bottom and restuffed. This one does have a cardboard cover, so I just cut it off at the near the shoulder, and I'll put the cardboard back over it. Well, while doing that, I also started removing the rust from the chassis. And that's going along fine. Kind of looks horrible now, but if I mask everything off and paint it with some copper paint, it'll look fine. However, while doing this, I noticed some things that struck me as odd, which is all these various holes that don't have anything in them. They're scattered all over the chassis. So I thought, well, I just happen to have another TS18 copper-clad chassis handy from a set that was too far gone to restore, so let's compare them side by side. Alright, here's the other TS18 chassis. This came out of a suitcase set that was missing the front cover and the back and had no CRT, so I've just been scavenging parts out of it. See all the caps has already gone here. Alright, so notice this does not have, for example, that square here, or the little slot here, or the slot over here. Well, on closer examination, a lot of these holes here, they're for tabs that are bent down and used for tie points. But this doesn't have them, but they have to be factory. I mean, those are clearly stamped out, and they're used to secure the circuitry. Okay, that's a little odd. Also notice that the parts are really prominently sticking out here. The terminal strip comes actually outside the edge of the copper strip here. Here, they're tucked well underneath. The terminal strip is set back quite a bit from that edge. Also notice the seam here is a bit different. Here it's straight down. Here comes out a bit, and then it's bent over. Something else curious, production date. It's upside down, but October 19th, 1949, and this is November, I think that's 16th, 1949. So these are made within weeks of each other. Now, who's to say when they stamped out the chassis versus when they stamped that date on it? I'm guessing the date is when they actually assembled it, not when they necessarily stamped out this chassis. Now, these are both TS18s. There is a TS18A, which was a successor to these. So, hey, maybe this is really a TS18A. Well, I happen to have a spare one of those, so I'll pop that up here and let's compare those two. Okay, this is a TS18A that came out of a Bakelite 8-inch 9T1 set. Bakelite cabinet had damage and the CRT was bad. The 8BP4 CRT is virtually impossible to find a replacement for, so this will probably also be destined for spare parts. Alright, so let's compare these two. Well, hey, this does have those cutouts and the notches for mounting points and whatnot. And it's got that same chamfered part up here. But there's some other changes, or differences rather. For example, this transformer is mounted on this side. On this set, it's mounted on the inside. Also, on this set, we've got this trimmer cap here, which does not exist on this set. And that rivet isn't blocking the hole. That rivet's here too. It's just kind of hard to see. It's right there. So, another odd thing about this I noticed while cleaning it is that this threaded collar that goes around it is not soldered to the chassis like it is on these and on these. But it is factory, I'm sure of it, because it is soldered below and it's very neatly tied into the circuitry. So my best guess is that this is sort of an evolutionary phase between the 18 and the 18A. Which is interesting and kind of cool. However, I cannot find any mention of this anywhere in the service literature. In fact, there's not much about the 18A either. Really, they just have a TS18 and they document a couple differences in the schematic for the 18A. But there are no mention of things like the transformer being mounted under here, and underneath quite a few parts have been rearranged. So if you're say using the SAMS, which has those photos of components, not quite as so handy when you're doing an 18A, because these won't line up. There's that transformer. They show it mounted on the inside, not the outside. And if you look, because the transformer's not here, they mounted other components. These mica caps don't even exist in the TS18, as far as I know. You certainly don't see them in this diagram, so life's a little bit tough, I guess, if you got a TS18A in terms of service info. And then there's this, which you call an 18A prime or 18A beta or something like that. So what does all that mean for me? Well, when it comes to doing an alignment, I don't know what to do with that. I don't know what it's for. Comparing the circuitry between these two, it's generally the same. Oh, and the terminal strip here, and this it's mounted back a little bit more, but it's basically the same. You can see these same. Here's a disc cap, resistor, ceramic tubular cap, I think, and bam, here we go, disc cap, resistor. So it's very similar. I'm going to have to trace out the circuit and see what that's for. I'm hoping that in this set, it's a fixed capacitor. In here, it's variable, but otherwise everything else is identical. So they might have thought at the time when they made this, maybe it was an experimental version, I don't know, that needed a little bit of tweaking. And otherwise it's identical and I can follow the alignment instructions for all this stuff. And then just tweak that by eye or by ear, depending on whether it's for audio or video. Well, maybe both, because I forget. This set, the audio and video go together through the IF stages, and the sound is split off after the detector. So that's where things stand. Do a little bit more corrosion removal, and then I'm just going to slap some primer on. I'll just do it by hand. I'll use some this good old stuff just to stabilize it, and later on maybe I'll paint it. And I'll remount that cap. And I want to go through and finish checking all the resistors down below. And then I'll try to draw this up. I also make a photocopy of the existing schematic and then try to figure out what the difference is in this set. And then, of course, see how it plays. And then maybe try to align it. I just noticed there's a date on this one, too. January 26, 1950. And this is November, so we got about a good 2 months production difference between these two sets. Okay, I finished installing the last rebuilt electrolytic and replaced the seleniums with diodes. So here goes the power-up check. I really hope I didn't make any mistakes. Okay, looks promising. Not really any better though. So when I say promising, I mean promising in that it powered up, but no real improvement. So, there's that capacitor issue, and I know I've been playing around with it and tweaking it while the set was off, while I was cleaning it, so I guess now would be as good a time as any to tweak it and see what effect it has. Now those aren't, that and the other two nearby are not inductors, they're actual variable capacitors. And I've not traced out the circuit for this one yet. But I'm adjusting it right now, so let's see what, if any, effect it has. It's all the way in now. I'm backing it out. Can't really say it has a huge effect, which is kind of what I figured. But experiment more with that later. Now this one has a big impact. This is another variable cap that I also mucked with while cleaning the chassis. That's about what it was. We seem to have screwed up the sound now. That's why you don't just blindly try to do alignments by playing with these controls, because there's too many interactions. Odds are you're not going to improve anything by just chance. The only reason I'm adjusting them at all is that I know I tweaked them a bit while cleaning and trying to figure out what the heck I was even looking at. Alright, so it seems like the sound is really misaligned from the video now. Here's a look underneath the chassis. Starting over here, we've got the RF amp, mixer oscillator, and then several IF stages. Now I've been examining this a bit more closely, and it's turning out to be even more interesting than I realized at first. So here's a trimmer cap. We already know that that's a variation. But check out these two coils. And every other TS4 and TS18 chassis I've ever seen, there are no tunable slugs on the bottom. They're just on the top. They look like these guys. This one does for sure, but not these two. If you look on the schematic, they just appear like this. So there's three of these. L10, L12, L13. But in my set, there's an extra winding and two extra leads on that core. Or actually there's another tunable core on it for these two stages. So What are those for? Well, as near as I can make out, they are traps. Just like in the Admiral 30A1, just like in the RCA 630TS. Very visible on the RCA. They're those coils with the cap in parallel of the tuning slug on top. No electrical connections to them, they just absorb a very specific frequency. These do have connections, I think, or at least on one side, but I think they're just going to ground. It's a little hard to trace out, but that's my theory so far. So these two would be traps. They would help shape the overall response to have very sharp cutoff at two frequencies. Now, once again, I do not have alignment instructions for this set, but I have not touched those, and I'm not going to for the time being. We'll see what response this has later on. So this leads me even more to think that this is some sort of experimental or small production run before the introduction of the TS-18 while they were tinkering with ways to improve performance. This might be a rather souped up TS-18 set. Maybe it's the best performing 7-inch Motorola set out there. I don't know. Now, as far as that trimmer cap and what it does, well, right now I can tell you it's not doing much of anything because this inductor is open. 3.3 microhenry going across here. I have kind of traced it out so far, and that's in series with this 33K resistor down to this bus, which I think is for AGC. I'm not entirely sure. But one thing I can tell you for sure is that with that circuit being open, there is no biasing voltage on this grid. The two caps are here, and that's it. So this grid is just floating. And that's not good, which means this tube is not operating in its normal range. So the oscillator's up here. This is the mixer. So the mixer is not biased properly for sure. For that matter, probably none of the other tubes are either. So I've been checking these resistors, and they are horribly off. I've already started replacing them. The 68 ohm measures about 130. This 1.2K measures about 400 ohms. This 1K was measuring about 1.3K. That's not so bad, but what's really bad is those low ohm resistors. That's 68K, and then there are 68 ohm, and there are 382 ohms on the subsequent IF stages. You see one here, and one here, and one here. These are all in the cathode circuit with bypass cap. That's equivalent of, like on a transistor, having the emitter capacitor resistor in parallel with a capacitor. That sets the operating mode and frequency response of the tube, I do believe. And having those be very off in value can't be good. So in other words, the gain of each of these tubes and the frequency response, I believe, is being compromised by all those bad caps. And the grid bias may very well be off too, if those other resistors are off so much. That's typically a 1K, I think. Or actually, it's kind of part of the coils here. So if these 100 ohm resistors are off, that's not good either. So, first thing I'm going to do is replace all the bad resistors I've already started to. And then we'll see how she performs. And I expect it's going to be a bit better. Oh, and I need to track down replacement for this. For the time being, though, I think I'll just jumper it, because that's pretty much how the original design is. And I will trace this out. There's a little bit more going on here. There's so here's the 33K resistor. It goes to that cap and that inductor. So basically down in here, I think at this node, on one of the other side, I think on, let's see, inductor, yeah, so right at there's an inductor here, and at the junction of the inductor and this resistor, that's where the trimmer cap is. So I presume that was there to somehow shape the response or perform some type of filtering action. It's just not there in the other revisions of this chassis. These circuit modifications are starting to make some sense. I just removed the 3.3 microhenry inductor, and when doing so, it was pretty obvious that the 33K resistor that had been routed over to that add-on trimmer cap was just cut off. And it used to go right here. That's how it goes in all the other TS18 chassis I have. So it was cut, bent over, just tack soldered onto the end of this, which then went over to this cap. This trimmer cap, which you can see is fairly loose on the bottom here, is also in parallel with this fixed capacitor, and that goes to ground. I'll just loosen it up and you can see the value. So it's 3 picofarad plus minus 0.25 picofarad. And judging from the other variable caps in the schematic, this guy is on the order of 0.5 to 3 picofarad, because it looks just like that oscillator trimmer cap. So here's where it is in the circuit. So this 33K resistor was cut, 3.3 microhenry inductor put in, going to pin 2, and then at that junction is the fixed cap in parallel with a trimmer cap going to ground. So for the time being, I'm inclined to just jumper that, or actually I prepared a little homebrew inductor. I don't know what the inductance is. It's probably less than 3.3 microhenry, but I figure I'll put that in there. And the other two, I'm pretty darn sure are traps. Both have 33 picofarad caps as near as I can make out, in parallel with a coil with a tunable slug, and one side is going to ground, the other side doesn't go to anything, I'm pretty sure. For now, I'm going to try it out with the simplest configuration, which was simply to reattach the 33K resistor to its original position, so I'm not going to use my little homebrew inductor. So this added trimmer cap is doing nothing now. It's not connected to anything. And I've only replaced 3 of the out-of-spec resistors so far. But I suspect having a bias on the grid of this 6AG5 RF amp tube is going to make a noticeable difference. Those replaced resistors probably will too. I was fooling around with this earlier, so I'm not sure which channel I left it on. Oh, yeah. Huh. Well, fortunately it's actually not a whole lot different than it had been. Seems like contrast has more of an effect now. That's what I was expecting, since the grid on the RF amp is not tied into the AGC bus, I believe.
You're watching the pt2o.com learning block on Cubo.
It sounds really off from the video now. Something else that seems odd is that this to me doesn't look like an issue of an alignment being off. It looks like there's an awful lot of interference coming in there too. Now there's no shield on this CRT. I think I've got one handy I can slide on there and ground that. Also, one of the tubes, this guy, should have a shield on it. But the tab where the shield attached to the chassis is broken off. There's just a little stub remaining. But I could slide a can over that too and see what effect it has. The shield for the CRT looks something like this. This would go over part of the cone, and then in addition there would be some metal, sheet metal wrapped around the neck. It's pretty crude affair, but it does offer some shielding. Putting the shielding in place seems to have helped a little bit. I also fiddled around a little bit with the IF coils. In particular, I found one that seemed to bring the sound and video back into alignment better, so I get a decent picture and sound at the same time. So next thing I'll do is replace the rest of those out-of-spec resistors. See how things play, and then I'll try putting a little curly Q inductor in there and see if that does anything. I finished replacing the out-of-tolerance resistors in the IF area, and instead of using my little curly Q homemade inductor, I dug up a 4.7 microhenry. Not quite 3.3 like the original, but it's better than an open circuit, so let's see if that makes any difference. Okay, one more test. Well, unfortunately, from the start of this video till now, really there's been no improvement, or very little improvement. Very frustrating. There's still just a heavy, what appears to be interference throughout. Alright, well, I think the next thing I'll do is do a few voltage checks, and if those seem okay, then I'll move on to doing alignment as best I can. Maybe the coils are just screwed up enough to make the picture look bad. While I ponder what may be wrong with this set, I'm going to leave you with one last thing. You may recall at the Arky Swap Fest recently, I picked up a 3JP12, a little CRT. And a couple months ago, I picked up a 3JP1 off of eBay. I think this is new old stock. Now, what these numbers mean is 3 is a screen diameter, 3 inches. This is the 7JP4, so it's 7 inches. The P in the number indicate phosphor and then the phosphor type. P1 is medium persistent green, typical early oscilloscopes. P4 is standard black and white TV phosphor. And P12 is a long persistence orange. J indicates the family. So, these all have the same base. And the same basic hookup. Same filament PIDs, grid, cathode, and deflection plates. So, if I was to just plug this into the set, for the most part, it should work. I say for the most part because there's one glaring difference, and that is this guy. And this also has it. These have a third anode. This just has an anode number 1 for focusing and anode number 2 for the high voltage acceleration, which is what this internal coating goes to. That goes to about 6,000 volts. Focus anode, I think, is between 1 or 2,000 volts, depending on how you adjust the focus control. These have 3 anodes. One is for focusing, and one is for, I think, a primary accelerator, and then there's a secondary accelerator, which is the third anode. So I think this ring is the second anode, as an insulator, and then the third anode, which connects up here, and it's called a post-deflection plate accelerator, because the deflection plates are around in here, and this comes after that. So, obviously, I need to connect this to something. This CRT does not have that, so I'd have to run a wire to this. The other issue is these run on much less voltage. This guy, 3,000 volts. This guy, I believe, around 1,000 or 1,500. And then the focusing anode is much less voltage, like between 250 and 500 volts. So if I was to plug this CRT into that, not only would I not have the right or any potential here, but the other anodes would be much, much too high potential, and they'd probably be arcing inside this. So my challenge is to figure out the most the least intrusive way to modify the set so I could try out these. So one, you need to cut the high voltage in half. But if I was to just say tinker with this high voltage or put a big resistor in there to cut it down, that would decrease the voltage throughout the whole chain back to the 6SL7, and it'd be running on much too low a voltage, and it'd be too low voltage on the deflection plates, and it wouldn't work right. So I'll draw the diagram and tinker with that more in the next segment, but for now I will leave things off here.